started. Happy Wednesday. So what we're going to talk today, still we are in designing sequential circuits. Today we're going to talk about other flip-flops more. We talked about JK flip-flop last class, but we didn't finish it. We're going to finish that one. And also we're going to go for T flip-flop. We're going to see if you can have T flip-flop, what is it, what we need to change. As far as we know, execution table, we can deal with any kind of flip-flop. Doesn't matter. Execution table is an important one. So let's get started. This is a question that we started last class. It was a 4-bit sequence recognizer. And the bits that we're supposed to detect is 1001. Is that important to know which pattern we are recognizing for designing? In your idea, what you are thinking? Do you think if I change, for example, that 1001 to 1101, is anything change in the circuit?
Yeah, our transition to our states change.
Yeah, that's right. It's changed.
Basically, the entire state was changed.
Everything changed. So that's important. What else? But if we change the type of flip-flop, what about that? A state change if we change the type of flip-flop? No, the state's not changing. But even transition table is not changing. Transition table is important. The thing that it's changing is after transition table when we want to find the inputs for flip-flops. In that case, we need to find the inputs for flip-flops based off the execution table. For flip-flop, we actually fill that table. So we're going to see that. This the milli states for detecting the pattern 1001 that we talked last class. We also draw the table, not just transition table, even from inputs. Last class, I just changed it to the better table. How we found that, we used execution table for JK flip-flop. JK executing table. So executing table showing from Q, capital Q, from the previous state to the next state. So this is the important one. So that's why we need to fill this table. We need to know. So if you remember, it was 0, 0, 0, all possibilities that are happening for Q and capital Q. So JK, if you remember, these two are acting as a memory. So in JK, memory is 0, 0. But also, here Q is 0 as well. So it means it's kind of resetting as well. So that's why this can be anything. That's why we have X here. This covering two cases. One is resetting, and the other one is memory. What about, so for these two, it's going to be similar. So here is memory, but it's set. Memory and set. So it's so memory and set. It means it can be here, and you're gonna have 1 here. But these two are toggle. So and in JK, when both of them are 1, so the toggle happening. So here you have X and 1, and here you have X and 1. Oh. And 0, am I right? Yeah, when the 1 and 1, yes, it's memory 0. Sorry, I just again made a mistake. 1, 0. Okay, so this is the table, and we fill this output for input for JK flip-flop based off this execution table. Okay, we did that for last class. And right now we want to find J0, K0, and J1 and K1. So it's 3 variables. So we have X, 0, and Q1 for all of them. I'm just going to do 1, and you can let's do for J0. So how we can do that? 0, 1, 0, 1. Oh. Maybe do K1. This part of my monitor is strange. Do for K1. So K1 is this one. 1, X1, X1, 0, okay, X0, X0. Am I right? Yes. So how we group this? These 4 together, because we can consider these don't cares 1, and these 2 don't care 0. So I just can group all of them together. We can make it bigger. That's the maximum. Okay, so let's go for this group. So in this group, what is the K1 gonna be? K1 is equal to, what is in common? Anything here in common? No, because they'll change it. But here we just have 1. 0 is common in all of them. What was the 0 for anyway? I forgot to write that. That's important. You need to see how is the arrangement of variables. But arrangement of variables is here. X, Q0, and Q1. This arrangement needs to be same as that. X is the most significant bit, Q0 and Q1. You can change it, but if you change that, anything changing here, you need to write this again. Anyway, in this case, what is K1? X or X bar? X bar. Yes, because it's 0. So it's X bar. Let's do for J1 as well. For J1 also we have X, Q0, and Q1. Okay. So for X1, for J1, sorry, we have 0, X, 1, X, 1, X, 1, X. Oh, this one is good. Change the color to another color like this. Okay. So what about this one? Can I do all of these together? Yeah. All of this. I think it's good. What about this? We have 1 extra 1 here. Can I make this 6 together? No, 6 is not allowed. But what about 4? 4 allowed. So we can do 1 4 here, another 4 here. That's good. So J1 gonna be again X, because this is 1, so it's going to be x, not x bar, plus, what about this 2? Q0. X plus Q0. Okay. That's it. So let's clean this up. Okay, I'm going to fill all of them like that. So we're going to find all of these inputs for 2 flip-flops. Because flip-flop is JK, it has 2 inputs. So we need to find the input for all of them. So we have 4 Boolean expressions. J0, K0, J1, and K1. Okay, what's the next step? Just draw it. So to do that, let's draw that. So this is the same, I just copy them here. To draw that, so here is also kind of important. This is 2 flip-flop. We consider this 0. So it's J0 and K0. This is Q0, J1 and K1, and Q1 bar, Q0 bar. Okay, so we need to find these 2. Most of the time, because we need all of these inputs, let's see which one we need. We need Q0, so we need this one. We need Q1, we need this. What about bar? We don't need anything else. We don't need Q bar. So we can just remove them. We don't need more. Make it. Okay, so bring these 2. Right? So we need them here. So here is this box is a combinational part. This is a combinational part, but I'm just gonna erase it, draw them, and then cover them because I don't know how big it's gonna be. Okay, so we also have an output, or maybe I remove this here for a space. So we have also output Z and one input X. Okay, so we have one output. We need to find these 4 inputs based off that. We also have clock and reset or set based off the initial state. We need to see which state is the initial. Here we consider 0 initial. If it's 0 initial, you need to just put them all reset. And is active low. Reset is active low. So imagine this is reset 1. Let us choose another color. So that's a kind of important as well. Just going to bring that out. That's reset. But reset is active low. So it needs to be 0 to make this 2 flip-flop reset. Okay? Oh. So you know that. Let's go back for other parts. So these 2 inputs are Q0 and Q1. So let's go for J0. J0 is just Q1. Okay, so just gonna directly connect this to this. For K0.
I think you mislabeled those.
Oh, I did. Yes, you're right. Zero, and this is 1. 0, and this is 1. Okay, so let's change the color again. So for J0 is Q1, so we're just going to connect this to this. For K0 is K or X. So X going to come here, and a Q1 is also here. You can connect to this. For that's part done. For J1, another OR. This is OR. It's not an OR. That's point. Also, this is not okay. And this OR is X. X is I'm gonna write later. And Q1, maybe I choose another color to 1 and X. That's it. And what about K1? K1 is X bar. So we're gonna have X bar here. And okay, maybe I just get from somewhere here and do X bar. That's it. And that's X. What about Z? Oh, we didn't compute Z. Oh.
Did you use Q0 anywhere?
What? Oh, the T0?
Should it be used on J1?
T0. Oh, X and Q1. This is X and this Q1. What's wrong?
I said Q0.
Oh.
Shouldn't Q0 be used on J1?
Oh. T0. I don't understand.
The equation up there is J1 equals X plus or X or Q0.
Yeah.
Your Q0 isn't connected to anything.
Oh, yes. Oh my God. What I did?
Connected it to Q1.
Yeah. Thank you. Yes, you're right. Okay, so that's Q0. J1 is Q0. Okay, so that's right. Is good. Do we have more Q1, Q0? Okay, that's it. What about output? I didn't. Is just 1, 1 and all 0. So it's going to be, we can make it simpler than that. X, Q0, Q1. So this is going to be 1 OR, big OR, 3 input, X, and Q1 and Q0. That's it. So as you can see, this part is a combinational logic. That's a purple one is a combinational logic. And this part is like a sequential part. We also have clock, of course. Clock is with edge trigger. Okay, I think I have a better version of that. Can I clean this? Of this version too. Okay. So that was JK flip-flop. So let's go for design that for D flip-flop as well. I'm not gonna because we know D is the simplest one. In D flip-flop, the execution table is all based off capital Q or next states, because D flip-flop is just passing whatever is input is passing out just when the clock coming. It's not doing anything extra, just kind of delaying. That's why it's called delay flip-flop. Sometimes D, not just data, also delay. How much delay? 1 clock. And it's exactly the same. So that's very simple. So we just need to copy whatever is in Q0 and Q1 in D1, D0, and D1. So the rest is just doing that. But instead of having 4 input, we have just 2 inputs, but they are a little more complex. So this one has XOR, and this one also 2 min terms. But Z is the same. Z is the same. That's the important part. Why Z is the same? Because Z is a kind of combining this Q0 and Q1 that creating with these 2 functions, is kind of related to D1 and D0. So if we draw this circle, I'm not going to do that. Again, I have it here. So I'm just going to complete this because this doesn't have reset, doesn't have clock. So for D flip-flop, we just have one input. So it's not hard to design it. But Z is the same, Q1, Q0, and X. But we need reset, clock. So let's do clock first. That's a clock. And what about reset? Reset is, let's put reset here. Okay, reset is active low. So we need to put one here, so this, and go in this, but that's fine because I have different colors, so they are not connected. They are just passing each other. Okay, so that's a reset and that's a clock. Okay, that was D flip-flop. What about T flip-flop? Okay, that's a new one. T flip-flop, toggle flip-flop is another one. Any question about this? You know how to do Carnot map and simplify the secant. You know how to arrange. We did like 10 examples. I hope you can at least answer these questions in exam. And I'm designing your homework, and your homework also have similar stuff. But because homework is open book, and you can use the slides to answer them, maybe it's not that challenge, but at exam is a little, you need to memorize everything. It's closed book and closed notes. So you need to challenge with this stuff. However, I'm not asking you to draw this, but I might ask you to find this out. And I'm going to ask you other stuff. For example, I might ask you, for example, if we start from state 0 as a first step, state, what's going to be a reset? Or if I say, for example, we are starting from state 2, what's going to be that? So you need to set kind of reset and set, because we have set 2. I didn't put set here, but this is another question. What is set right now? Imagine this is set. What is this now? So reset is when you make it 0, is make it reset. Other than that is 1. So, okay, so what about set? You know set? If set becomes 1, it makes them set. So if it becomes 0, it's not doing anything. So it needs to be 1 then, okay? So because it's active low. So it always needs to be 1. I will ask you these questions, this kind of question. Okay? For the other design also, you should put that one too. If you start from 0. Okay. That's it. Or might ask you, for example, about some details, but mostly about resetting and setting. Or I can give you one picture like that, and I ask you other stuff. Go for P flip-flop. So we are doing same question, same problem, but just changing the flip-flop. So till transition table, everything's same. The state same. The state diagram is the same. A transition is the same. But here we need to choose the type of the flip-flop and draw a flip-flop table or flip-flop inputs. So from here, we're going to look at the T transition, T execution table. T executing table. So in T executing table, if you remember, has one input and two outputs, Q and Q bar. Okay. T is 0, act as a memory. So T is 0 is memory, and T is 1 is toggle. Just these two states, toggle and memory. But in here, we have 4 cases. So we need to fill this part. So we have 4 cases. So 2 of them are not changing. Q is same. So it means these 2 are memory. So for memory, we just need to put T. This is T, 0. So memory. And in this 2 is toggling. So for toggling, we put 1. That was, it's not difficult. However, I'm just going to give you this part. I'm just going to give this execution table for your examples, for your questions. Okay, but we found that. So that's done. Now, based off this, let I clean this up. Let's fill this T0 and T1. Fill the table. Okay. First, go for Q0. Q0 is these 2 columns. So we need to see one by one, the output is 0 or 1. First 0, 0, 0 is memory. So memory means 0. 0, 1 is toggle, 1. 1, 1, 0, toggle, 1. 0, memory, 0, memory, toggle, and toggle. Is that right? Let's go for the next one. In this. Okay, Q1. 0, memory, 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 toggle, toggle, memory, right? Check again. Mistake. Okay, memory 0, toggle. Oh yeah, I made a mistake. Okay, memory, toggle, 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 memory, toggle. Oh yeah, that's correct. Make that mistake. Don't know. I think I. All right, no worry. No problem. Okay, so that's the thing that we need to use for drawing Carnot map and find the Boolean expressions. Any question? Yeah, I think it's not that bad. Okay. The result. So you can see that is the same, just different color. Okay, no, and right now we have the table input for flip-flops, and we can find, use Carnot map to find expressions. One for T0 and one for T1. first for T0, we're just gonna fill it from top to down, 0, 1, 0, 1, 0, 0, 1, 1. These two are 0. It's not showing. I don't know why. Okay, that's 1. Oh, this is for X, Q1 and Q0 and Q1. Same X, Q0 and Q1. Here we have T1, 0, 1, 1, 1, 1, 0, 1, 0. Good. Okay, so let's group them. What about this? These two can be like. What about these two? These two a group? It's not good because I'm gonna group these two, and we don't need another extra group. So we're gonna have two groups. One here, one here. What about this one? This is a little. Yeah, they're not arranged good. These two. Oh, yeah, that doesn't matter. If we consider these two, one group, and these two another group, and these two another group. I think that's the best one. You always have multiple choice here. Like you can get this and this, but they still are gonna have three min terms. Anyway, so let's see what is the result. If we do that, we're gonna get T0 and T1 this. I just want to check them. For this one is X bar Q1, correct? And for this one, X and Q0, correct? For this one, T1, X and Q1 bar, correct? For these two, they both sharing one X bar, and one is Q0 and one is Q1. That's correct too. And Z is the same. Z is not changing. Z is the same because it's just 1, 1 at the end. Okay, so to draw that, okay, so because this is T, let's draw that together. We have time. So how we're gonna start? We start with the flip-flops T0 and T1 and their outputs. Here, for example, Q0, Q1. Okay, that's the output. We have one input X. Let's consider X somewhere here, for example. We have X. And also we have clock and other things that we can draw them later. And the output, we just can make it somewhere here. Output Z. Okay, so let's go for T1. So to do T1, T0 first. T0 is OR. And two ANDs. This is one AND. This is another AND. One OR. One OR. And ANDs again. One AND and this AND. And one of them is a little complicated because it has another OR. Okay, so let's do the rest inside. Okay, so we need to have Q0 and Q1. We just bring them out. Q1 and Q0. Okay, so good. So far, so good. Let's go for T0. T0. X bar. This is X. X bar. Okay, X bar coming. One of them. Okay. Then X0 coming and X coming. That's good. That done. Color another one. T1. X. This is X. And Q1 bar. Q1 bar. That here, and this is X. Okay, that's another one. And X bar that we already have it is X bar. And what about, I want to update things here. Okay, we have X bar. We need Q bar plus, okay, this is one OR. One OR here. Oh, that's, we have one OR for Q1 or Q0, and then AND it with X bar. Okay, and we can bring X bar here, and here, and here. Done. Right? Yes, I think so. That's T1, and that's, and Z. What is Z? Z is Q1 and X. Okay, let's change the color. X. X. And they are just using one OR, one from this, one from this. That's it. This is Z output, this is X input, and this is circuits. This part can consider as a combinational logic. That's the sequential part. And for inputs, because they both need to be a zero, initial zero, these two reset and be to reset, active low, and set, this is reset. And set B1, I'm not going to draw it, and clock is also, there is no space to draw that, but this is clock. That's it. Any question? Okay. So that was actually T flip-flop, designing with T flip-flop. And the JK flip-flop look a little, at least in terms of logic, it look a little simpler, isn't it?
That's the flip-flop itself and
Yes. Yes. You can see the advantage of JK flip-flop because, however, JK flip-flop is more complex, but in terms of design, the design becomes simpler because of having two inputs. However, we did four K-map, but even though we use four K-map, this combinational logic becomes simpler. That's important advantage of using JK flop. So I also have that. Okay, so I think we are done for this class. We are done with designing sequential circuits. Next class, we're going to talk a little bit about, not that much deep. I mean, next class is Friday and also the week after. We're going to talk a little bit about this new topics, but mostly we're going to concentrate in your exam and